Hello, everyone. Welcome to the second episode of our Investigating Incident series and the actual start of informational content. And for our first video, we're gonna do log analysis language basics. So, Surya, what is log analysis and how does that tie into investigating incidents?
Yeah, for sure. So I would say, in general, in most cases, when we're looking at investigating stuff, we usually have questions that we want to answer, right? For example, we have like, hey, Kev, you're failing multiple logons, right? And I want to know why this is happening and how this is happening, right? The information that we're looking for is in logs. These logs are generally stored in a SIEM, which is like a security information and event management tool, basically to find or filter the information to the required result we want, basically to answer the question. We use a language, right? And this language helps us basically filter through all of those logs and find the required information through all of these logs, right? And that's the main
Interesting.
purpose of a log analysis language.
Okay, so how does that specifically tie with security incident?
Yeah, I would say it ties into all the phases from when you detect the incident to it being triggered to it concluding and then you continuously monitoring at the end. So basically, what I mean is that when you initially trigger an incident, for example, Kev, I get an incident alert. So that alert is from a query, right? Like this query will run and it's like, if I get any results, trigger an alert or something along the lines of like, if this field matches this, then trigger an alert. So even the initial trigger itself is a log language query, right? And when you go further down, when you're investigating stuff, so here you're going through those logs now. You're trying to build context around the incident and determine whether it's a true positive or false positive. And then you're trying to like scope and triage the incident. And then when you go further down into the change, like after you contain and then you remediate, you're like, is this like, am I like after you, for example, you implemented certain firewall rule changes like, okay, I'll block all traffic from this IP, but is it actually blocked properly, right? So you can check all of those in like the later phases via those logs. So throughout the whole incident cycle, you're always using logs, you're always monitoring. That's the keyword I would use. You're always monitoring the information that's coming and you're analyzing that information to build context around it. So you're analyzing, hey, have I done my investigation phase to a certain level? Cool. Containment, is that going good? Is my remediation working fine? Right? So to go through all of those steps, you always are using logs.
To summarize, all of the useful information we need during a security incident, all the way from finding out in the first place that an incident has happened to all the way to tracing back the steps of an attacker, finding out what have they done and how they have managed to do that. We can do that from the logs because that they are the source of truth.
Yeah.
So the logs are like our digital crime scene. That's where we can find all the evidences of what has happened and how it has happened.
Yes.
Which is super useful, and I'm super excited to learn. But I know that if logs are in a crime scene, we need a proper way to investigate that crime scene, and that's where a log analysis language comes in. And so, Suya, what log analysis language are we going to use?
There are many different log analysis tools that are there. So we call them as SIEMs. So there are many different SIEMs available in the market. So you have Splunk, you have Sentinel, you have Elastic. So in this series, we'll be particularly using KQL, which is for Azure Sentinel, also known as Custo Query Language. So to start off with, let's look at some basic queries, right? So the first things first, where does the information get stored? So the information in Sentinel, in this case, and in most SIEMs, get stored in some sort of tables or some sort of sources, right? So in this case, in Azure Sentinel, we have it stored in tables. So I have my audit logs here, like activity, Cisco umbrella.
Hold on a second.
Yeah.
Please tell me quickly, what are we looking at? What are the different areas of the screen?
Sure. So firstly, I am in my Microsoft Sentinel space. So Microsoft Sentinel is a service within Azure. I am in the Sentinel logs space. So it's called as Sentinel, and then you go and go to, so if I show
So
here,
this is the crime
Sentinel,
scene.
yeah, Sentinel logs. Anyway, so this is where we have access to all our tables.
So it's like a dashboard where we
Mm-hmm.
can access our data.
Yes, exactly. So, so the key in Sentinel is like the data is stored in some way, shape, or form, right? I said the place where the data is stored in general, or always, is like in tables, right? Or you have it like in other external sources or other supplementary sources that you can access to. But the primary way that we query information is via the tables that are ingested into your scene. So I have some sample data that I've ingested to showcase the features. So the first thing we have is tables, right? So in the left section, we have is like areas where you can have pre-filled queries, functions, and so on. But the main part is the tables. So in this, I have a set of custom tables that I've ingested into the Sentinel workspace that I have. In the top, we have the run to run the query, basically the time range to select like how long do you want to look back at, and other options that are available if you want to export and format your query.
Okay.
Lastly, the below section, the section below here is where I'm writing my queries, and the section below that is where the results are displayed. So the
Sounds
first
good.
things first is let's just look at a table. So I have a table here. I've just called it as sign-in logs. And let's look at what are the sign-in logs that I have. So here I have some sign-in logs. If I can just make it a bit bigger. So here I have some sign-in logs. There are a set of rows that we have, and those rows have different columns, right? And those columns have set of information. So in this case, there's been a login activity from KP, and it has failed because the user account has been disabled, right? So that's that information, and then the result is that the user account is disabled. The account has been disabled by the administrator. All right. And who's the identity? Who is this for? This is for John S. So the user whose account has been attempted to log on is John S. So now the first thing I'm seeing is that I'm getting all of this information. So how many results am I getting? I'm getting like 60 results. Damn, man. That's a lot of results to go to. Usually it's like thousands in some cases, but in this case, I've just ingested a small portion of data. So,
Yeah.
so the first step usually is like you need to understand what is in the table, right? So to do that, usually we use the limit operator. So limit is a operator in Sentinel or
What is
KQL.
an operator?
Operator is you could say it's a function that you use to basically filter out the data. Right? So in this case, I want to filter just like the way I should say is like I want to limit the results I'm getting to just 50 rows. All right.
Okay. Yeah.
So the way I'm doing that is that I'm using a limit operator. So before I get a bit more to the limit operator, there's one key part here. If you see, there's a pipe, right? So in most themes, like you'll usually use a pipe operator of some way, shape, or form. What this pipe operator does is basically it's like, hey, take the results you get from this, okay, and then to those results apply this clause. All right. So I'm going to get the results. So I got these results, these 60 rows. And to those 60 rows, I'm going to limit it, for example, in this case, to like 10. Oh, sorry. 10 rows. So I'm like, okay, take these. So all 60 rows come. And then I want to take those 10 rows. So I just use limit. So the main purpose of using limit, if you want to know, is basically like, hey, what are the columns I have? What kind of information I'm getting is to understand your table so that you can write queries on it.
Yeah.
Yep.
Because when you're dealing with a new table, or as an investigator, you wouldn't be familiar with everything and anything, right? So when we see something new, we need to understand its shape and form and structure. And if we have thousands of rows of information, it's very easy to get lost in that.
Yep.
So we want to be first getting a few results in, so we get a shape, we get an idea of the shape and form of the data and the table, and then so we can perform fine grain investigations more on it.
Just to add another point, a really good reason to use limit is to limit the amount of time it takes to run the query, basically. If you
Yeah.
have 10,000 records, right, it's going to take some time to load all
Ages.
that
Ages.
information. Not ages, I would say it take like few seconds, but those few seconds feels like ages for sure.
Depending on, like, maybe some logs it takes a few seconds, but depending on the complexity of your query, right, things can get really, really complex.
Yeah.
And let's say if we were dealing with an actual environment, for example, we don't use Sentinel, we use Splunk at my company, and even then when I'm trying to run some Splunk query, it can sometimes
Yeah.
takes ages
If you just
because of
specify the source, it's going to take forever. So you need to limit the information so your queries can process faster.
yeah
Like
yeah
it takes, there's two parts to a query if you want to think about it when it's being run. The first part is it fetching the information. So it's like, I need to get all that information. So it gets that information. And then the second part is like, it needs to load that information, right?
yeah
For it to be displayed to us. So those are the two parts that happen. And usually in Sentinel's case, at least, it fetches the information in a decent speed, but it takes longer to load because there's a lot of information to load, right? So that
yeah,
takes a longer
absolutely.
time. So basically, I'm just going to run this limit operator. What it's basically going to do is just limit it to 10 rows. So you can see here, it's just 10 rows, and I can see what are the different options I have. So I'm like, let's see, what are some interesting columns here? Result type, that's a pretty interesting column. And then there's this result description column. So this column is basically saying, oh, what does this result type mean? Just in general, for sign-in logs in Windows is basically 0 means you have passed, like it was a successful sign-in, and if there's anything else, then there's some error, basically, right? So like, oh, let's get some more information on this, right? So I want to know like what are the different types of results I can get in my result type, right? So to do that, basically what I can do is run this query. So a different operator here is called distinct. All right. The goal here is I just want to know what are the different types of results I can get in this column, right? So if I run this, I'll just see all the results I can get it, all the different types of results that were there in this table for this column. So those were 0, 50057, 16000, 50058, right? But then I'm like, I also would like to know what is like the description, right? So like this is not enough information for me. I also like to know what those errors mean, right? So with distinct, you can join it with multiple columns. It's not restrictive to one specific column. And you can even use star to find all the distinct records available within your table, right? So across the table, what is the distinct combination that you have?
Okay.
So if I run this, so I'll also get the information about those rows, those result types. So 50057, basically user account is disabled. 1600 is an other, interesting. 50058 is that application tried to perform a silent and the user could not be signed in silently.
I see.
The application needs to start an interactive flow, giving users the option to sign in, contact the
So,
opponent.
if I understand correctly, what you wanted to do is understand the result type and the code you were getting,
Exactly.
right? So you realize that the result type has result description, but there are multiple fields with maybe the 16,000 result type row.
Yeah.
So using the distinct operator on those two column headers, you essentially combed through all the very distinct rows, and so you can see the description of those rows. That gives you an idea of what are the different type of results are out there.
Yes, exactly. Just to get an understanding, like what are the different options there, right? So again, all we've been doing here is like filtering to the through the data to reduce the number of rows that we are seeing. Right?
I wanted to very quickly pause and sort of add a side note that when you are doing an incident response, most of the time you wouldn't have a proper picture. You wouldn't have the complete picture of everything. So as an incident responder, you would be needing to do this kind of small interrogative steps to to amplify your understanding of the scenario and have more and more information. So think of like a detective who's trying to figure out the case. You cannot figure out the entire case in one go.
Yeah.
You sort of need to just solve it chunk by chunk and then link all the data together. And that's what we are trying to show here.
Yes. So let's get into one of the most important and most useful clauses out of all. So now I have like information. So I'm like, okay, cool. So there's this one where I'm seeing user, like a user's account, but they're like sign-in attempts happening against a disabled account. Basically, there's this disabled user account, and there's sign-ins happening against this account. That's a bit odd. I would like to know more information on that, right? So basically, what I do is I use the where clause, right? The where is surely one of the most important clauses in Sentinel or in KQL in general. Basically, what this allows us to do is that it allows us to filter based on strings. So basically, I'm able to perform string comparisons. Like I'm checking like, hey, is it equal to this result? Then give me those rows. Basically, it'll filter out those rows that match this or do not match this. You can do both, right? So in this case, what I want to do is I want to see all the rows where the result is 50057, right? So I select that, run that query, and voila. So I have all the results where it's basically here. You can see all those different results where the result type is 50057, right? So these are the different cases. And then you can go and find more information in regards to each of those results. Like,
I want to give a very practical example, which I've actually come across. Is during a security incident, we found a particular IP address that we suspected is the bad actor, and we wanted to identify the blast radius, which means where that bad actor has been so far. So what we basically did is take that IP address and put inside a where clause where IP address equals to this, and show me all the unique resource IP addresses that bad actor has been, and voila, we could see it where the attacker has been so far.
Yeah.
So that's like a practical example and put it into a bit more context.
Where is super useful. There are very different clauses that or operators you can use with it, string operators. So in this case, I've just showed one where it's equal to. So equal to means anywhere where it contains this value. It doesn't need to match the case. It just needs to contain that exact value, and it will find all those records. The option here with the tilde sign will like make it case sensitive. So now I can show you a way we can use contains, right? So in this case, we're saying location details _s where country or region contains KP, right? So I just want to see in this column, is there anywhere the value KP, right? So to do that, I can just use contains. So I can show that here. So do that with contains. So wait, no, I need to change my column first. So column location _ details s, that's the column, contains KP. So anywhere where this result is happening, have that. Boom. So wherever location _ details contains KP. So all those results show up, right? So that's other ways you can use it. So there are two things to finish off with. One is, what if I don't know where the information is, right? Sometimes you end up in a situation where you just want to find wherever this information is located, right? Sometimes there might be some places where this information might be available that you do not know of. And a really useful command for that in KQL is search. So I can just search 50057. What this will do is that it'll find all records where 50057 is available in whatever table. So here I can see in security alert, there's this one here. See here, identifies multiple failed attempts. There's one there. There's few in security incident. Again here, identifies his IPs. There's on silent logs. That's the one we were seeing. There are other security alerts too, regards to that. So these are all the places where this specific keyword exists, right? The last thing I want to finish up with is the concept of time, right? When we go to the next episode, we will be using time as the first pipe. So first clause that we have is going to be time. So in this case, I'm just showing here using the time range here. So to manage time, we usually use a clause called as time is generated with where. So where time generated is greater than or equal to go, and I'm looking for like the last 7 days, right? So basically what this query does is that it goes and checks the results for the last 7 days and then sees if there's any values in those last 7 days that contains the value KP. So here's 18, that's like 7 days ago, and that contains the value KP. So it's like that. Why time is super important is the fact that all those clauses, the best way to filter out the amount of information that we are looking through is time, right? So if we know when an incident is happening, for example, we know the incident happened in the last 24 hours. So then I can limit my search towards the last 24 hours, right? To find an initial set of like entry points and other information, and then go dig deeper. Like, we can go further back if necessary, but that's like an initial starting point. And then you can expand and contract your scope as need be, right? But time is surely one of the most important and one of the most effective clauses to be ever written first, is because time allows you to filter out the most amount of information possible. So if you're limiting it to 1 day, your amount of records from like 60 can just reduce to like way lower, right? So time is very important.
Awesome. Cool.
And that's it for our second episode, or our first one, going through the basics of KQL. In the next episode, we'll be going over some more advanced commands such as summarize, project, and so on, which we'll be using to like summarize the information that we're getting from different rows, columns, and how we can utilize that information to come to a conclusion or bring some context to an incident.
Awesome. Thank you so much for that, Surya, and thanks to our audience.
Thanks,
I'm looking forward to the next video.
And thanks, audience. See you guys. Bye.